All right, welcome back. We are now in section 2.5, which is zeros of polynomial functions. So to get things started, let's look at the fundamental theorem of algebra, which states that if f of x is a polynomial of degree n, where n is greater than 0, then f has at least one 0 in the complex number system. Well, keep in mind that the complex number system means it could be fully real, a real 0, it might be imaginary, or it might be a combination of real and imaginary. So, but there should be at least one in for any polynomial of degree n, where n is greater than 0. Now let's put that into a more understandable perspective. So from this theorem, we can get a relationship between the number of zeros for a polynomial. So linear factorization theorem. So if f of x is a polynomial of degree n, where n is greater than 0, then f of x has precisely n linear factors, f of x equal to some constant times each of those linear factors all the way up to n. And all of those numbers are complex numbers. So again, some of them might be real, some of them might be imaginary, some might be both. So in this case, we look at a specific example that has multiple zeros or repeated zeros, as we said before. So when we factor this, we get x plus 4 times x plus 4. So it seems like there's one 0 because it's repeated. But technically, we have to treat this as two zeros. So repeated zeros is included in that. So let's frame the whole thing. If we have complex zeros, anytime we have a complex 0, so where it has both an imaginary and real component to it, then there has to be a pair that's associated with that. So if you got one complex 0, you have to have its conjugate. And remember, we talked about conjugates in the previous section for division. It's the same thing. So if I know that a plus bi is a 0, then I also know that a minus bi is a 0. They both have to be in there no matter what. So, okay. So we have a sense of that, of how many zeros a polynomial must have, and we know that complex zeros should come in conjugate pairs. So if you have one, you have the one that's associated with it. So now let's try to work backwards a little bit with these. So what happens if we have zeros to start with and they wanted you to give the polynomial that makes that happen? Well, so this question says find a polynomial function with real coefficients that has the given roots or the given zeros. Remember, roots is just another way of saying zeros. Now, we did a problem similar to this in previous videos. So where we had to kind of work backwards and rewrite it as a factor. So that's kind of what we're going to be doing here. So if -3 is a 0, we should know that x plus 3 is a factor. Remember, the sign's got to switch. So if it's -3, it's going to be a +3. If it's +5, it's going to be a -5. Now, they want a polynomial equation. So what do they mean by that? All you have to do is just set it equal to 0. Now, if they didn't have that word in there, if they didn't have equation in there, and they just said find the polynomial, that's when you would say something like f of x equals those two factors. So in this case, they want an equation, so just set it equal to 0. And now just FOIL it out. So the inside and the outside is going to give you a -2x, and then the last is a -15. And so there would be your answer. Now, is this the only one? And your answer should be no. There are other ones that could possibly work. How do we know that? Well, remember up above, what was the one thing that they did is that they multiplied it by a constant. So if we multiplied our answer by any constant, it would still have those same zeros. So we can multiply the whole thing by 2, and that would be a possible answer. We wanted to multiply it by -2. That would be another answer. So there's an infinite number of possibilities, but the standard one would be without the parentheses, without that -2. And that's what I would recommend you do. So, all right, let's take a look at more complicated ones now. So when we have a -4i and a +4i, how do we get our polynomial from that? It's the same way. It's exactly the same way. So we would write them as factors first. So x plus 4i because of the minus, and then the other one's going to be a -4i. And we can set it equal to 0. All right, and now we got to multiply this all out. So we're going to get an x squared. So we got a +4ix and a -4ix. So those are going to cancel. And so all that we have left is just the last, which is going to be a -16i squared. And remember, we just learned that I squared is equal to -1. So -1 times a -16 is a +16. So our polynomial equation should be x squared plus 16 equals 0. All right, so we got fully real zeros, fully imaginary zeros. What about those complex ones? All right, so this one's got a little bit of both. It's got a real 0 of 1, but it's got a complex 0 of 2 minus 3i. Well, we still do the same thing, but don't forget what we just set up here is that it has to come in conjugate pairs. So if this is a 0, we automatically know that 2 plus 3i must be another 0 for this. And so now we can start working on it. So the x minus 1 takes care of the real 0, and then you might remember this from before. So we got to subtract each of those zeros from x. And remember, if you use the extra brackets just to kind of keep things separated, it's not a bad idea. So I would wait on doing anything with this x minus 1. Remember, because conjugate pairs have nice little things that happen if you rework them a little differently. Oh, and don't forget to put this equal to 0. So remember, what we said before was we move the parentheses around the first two terms instead. And when we distribute this negative in, that's going to change this to a plus 3i. And very similar on the other one, and this will become a minus 3i. So again, we're distributing the negative into those parentheses, and then we're just shifting the parentheses around the first two. Okay, so now it doesn't really look better, but it will be if you recall. So this would give us an x minus 1. So our firsts are going to be that binomial squared. Our inside and outside will cancel. So all that's left is the last, which is going to be a minus 9i squared. And again, that's equal to 0. And let's go one more step down here. So we got x minus 1. And I think we can get rid of the brackets now. So if we FOIL this out, this is going to give us an x squared minus 4x plus 4. And now I squared is negative 1. Negative 1 times negative 9 is a positive 9. And we'll just skate over here. So now we're almost there. So minus 4x. 4 and 9 is 13. And now everything's real. We don't have any imaginary stuff anymore. which is what we want, because again, we want real coefficients in our polynomial, not imaginary ones. So let's finish this off. Let's multiply the x in first. So the x is going to bump up all of those by 1 power. Let's multiply the negative 1 in. So negative 1, whoops, not negative 4, just a negative 1x squared, a positive 4x, and then a minus 13. And so now, if I move my head out of the way again, we can add and finish this off. And so there, there's your answer. So x to the third minus 5x squared plus 17x minus 13 equals 0. All right, I think that's a good place to stop, and we'll pick up the rest, or at least a little bit more, in the next video. Take care.